In the previous lecture, we talked about homogeneous second order partial differential equation, so ordinary differential equation. Come. And we solved some examples about it. And instead we have three cases for homogeneous second order differential equation. We said if the characteristic equation has two different real solutions, if the solutions are equal, and also if the solutions are complex. We have these three cases, and we solve the examples about each of these cases. Now we have solution to non-homogeneous equation. For non-homogeneous equation, we said if the right hand side means f of x to be 0, that's homogeneous. So if f of x is not 0, it means this is the general form of second order linear differential equation. Here we have f of x. F of x is not 0. F of x is not 0. But for homogeneous, it's 0. We say this differential equation is second order for non-homogeneous differential equation, linear differential equation. Here we have two types of solutions. One depends on the left hand side. I mean, we equal the right hand side to 0, and then we do the same as we did before for finding the general solution of homogeneous equation. We are going to find that solution, and it will be the homogeneous solution. And then we are going to find another part of the solution, which is particular solution. This depends on the right hand side. For this one, it's the same as the previous one, the same as the homogeneous. And here you have yp of x, which is the particular solution. This solution depends on the right hand side. If this exponential function, if this polynomial, if this trigonometric functions, and so on. Okay. Here we talk about those cases if the right hand side do not be 0. We can solve this equation by either these two methods. First, we have method of undetermined coefficient, and also method of variation of parameters. We have these two methods for solving equations of this type. First, let's talk about method of undetermined coefficients. Method of undetermined coefficients. Here we have four cases. As I said, for yp, we say y, which is the solution, equals yh, which is the homogeneous solution, the one which we talked about last lecture, plus yp. Yp is the particular solution. For finding particular solution, we have four cases. And for this one, we have three cases, as we talked about. Yeah, we have three cases. But for this one, we have four cases for finding particular solution. As I said, for particular solution, we just focus on the right-hand side. Okay, it depends on the right-hand side. In case one, and this is for finding the particular solution, yp, we say if f of x to be a polynomial of degree n. That means if the right-hand side is a polynomial of degree n. If you have a degree n polynomial in the right-hand side. This is the first case. In the second case, we say if the right-hand side is an exponential function. If this an exponential function. If f of x to be an exponential function. And then if f of x to be sine or cosine function. To be sine or cosine function. Then the last case is if we have the sum of the above cases. For example, if we have sine x plus e to the power 2x. Here, in this case, how to deal with this one, how to find the particular solution for this one. Okay, that means if we have the sum of these three cases, let's say two of them or three of them. Okay, This for case 4. We have these 4 cases for finding YP, which is the particular solution. First case, we say if the right-hand side is a polynomial of degree n. If the right-hand side is a polynomial of degree n. This is the general form of a polynomial of degree n. We say YP equals. That means if the right-hand side is a polynomial of degree n, we say YP equals x to the power r times Cn, that's a constant, x to the power n. We can say a x to the power n plus b x to the power n minus 1 plus 2 up to a constant, let's say z. Okay, we say we decrease the, we write down a general form of polynomial as the same degree as we have in the right-hand side. For example, if in the right-hand side we have f of x, if f of x, is the right-hand side to be x squared plus 2. What's the particular solution for this one? We say YP equals a x squared plus bx plus c. We must write down the general form of degree 2 polynomial. So what if we have let's say only x cubed plus, let's say, x squared. How about this one? This is a polynomial of degree 3. So you write down YP as a x cubed plus b x squared plus cx plus d. Okay, we write down the general form of that polynomial to the same degree as f of x. So what if we have only, let's say, x? Let's say if we have x, 2x. What's the particular solution here? We say YP is ax as a polynomial of degree 1 plus b. This is the general form of a polynomial of degree 1. If this is degree n, we start from degree n to a constant. Okay, for all degrees. So this is how to write down YP. Here you have x to the power r. Why do we write down this x to the power r? Most of the cases we write down r to be 0. That means we have no x to the power r. If r to be 0, you get 1 there. In which case, we give degrees 1, 2, and so on to r. We say if there is a similarity between YH, what's YH? YH is the homogeneous solution. If there's a similarity between terms here and the terms of YP, here we should put 1 to r. If there is still a similarity, we give 2 to the power. Okay, we give 2 to r. So this is how to find YP. Here we have an example. In the example, it will be much clearer. We have given this second order linear differential equation, and it's not homogeneous because the right hand side is not 0. So what's YH? We say to find YH, we should find the characteristic equation. We say for YH, what we do? We say y double prime plus y prime minus 2y equals 0. This for YH. We just write down the homogeneous parts. We put 0 to the right hand side. This for YH. How to solve this? This is the same as we talked about yesterday. We say here you have m squared. We are going to write down the characteristic equation, which is m squared plus m minus 2 equals 0. And here we get 2 different values for m. We can make it into 2 brackets. We get m plus minus 2 minus 1. And here we get m1 equals negative 2. And m2 equals 1 plus 1. Is it? Yes. اي كان هو homogeneous واتا لا راس هرشي صفر يعني اي كان بس صفر بو هرشي يعني اقل لا راس واتا f of x اكين بس صفر f of x اوكي دي ايه بالي
تو يعني لما شجع حسابي واقعي باوري كله لا يكسانا كا يكشف مش كذا اللي تو باوري كتوان سنة كتوان
ها
بوجي أو ده شرايك كده جارو كده
look here we have it to the right hand side you mean this one okay okay so here what we say do you mean this one why it's degree 2 it's not degree 3
no I mean y double dash plus y dash
okay y double dash plus y dash okay what's your question
my question is if the in another side the sphere changes for another
this one
yes the equation will be different or it can be the same
look
is it related to the other side or not
no
why
this doesn't depend on the right hand side okay it's okay here we use the right hand it's not related to the left hand side okay we use the right hand side for only finding yp okay
I mean for identification of whether it's homogeneous or not
okay that's not homogeneous because the right hand side is a polynomial it's f of x if you have f of x look only the y terms should be in the left only the y terms y prime y double prime y triple prime and so on only those should be in the left حتى نها كوايت يا y prime هاشتاج اول لا يشبه هرش ما بين الراس اغلى الراس هيك تيانا ما هيك تيانا بو او كانت عليه homogeneous برام لي الراس اكس دوجا ناقص اكس مان اما نخشيك واي تيانيه this f of x
so the result ka awaya result yawi ke amamane result ko tayi yan ihangawa kan
اما اس اي كم هنغاو لبلو اروين بو
result ko tayi yan ihangawa kan
كوتاي okay we are going to find the solution what's the solution the solution is y equals yh plus yp we must find these two for yh we say we let f of x to be 0 that means we are going to check the homogeneous part the homogeneous part so the right hand side becomes 0 and what we get we have this equation second order linear homogeneous differential equation we solve the same as we solved the equations yesterday now we have two different values for the characteristic equation which are -2 and 1 so the general form of the solution is y equals yh equals a e to the power m1x plus b e to the power m2x is it because here we have two different values for x so this is the solution and now we are going to write down the solution we say yh equals a e to the power minus 2x plus b e to the power x 1x which is x so this is yh this is the homogeneous solution and now we try to find the particular solution we now try to find the particular solution look for particular solution we say we have a polynomial of degree 2 in the right hand side I'm going to clean this one because it's solved here okay because that's solved there to find the particular solution what we do we are going to write down the particular solution for the right hand side we depend on the right hand side for finding the particular solution look at the right hand side as a polynomial of degree 2 so the general form of a polynomial of degree 2 is yp equals a We used A and B, so now we use C, D, and so on. Okay, C x squared plus dx plus E. This is the general form of a polynomial of degree 2. Now, what we do here, we should find the values of C, D, and E. We should find the values of C, D, and E. How? In the equation, we have y double prime, y prime, and y. This is y. How about y prime? We should find the derivatives as you have here for yp. Y prime of p equals. Here, we take the derivative for this function, which equals 2cx plus d. Is it? And then y double prime of p equals 2c. Now we replace y by yp, y prime by y prime of p, y double prime by y double prime of p in the differential equation. So here in this differential equation here, what we do, we are going to replace y by this polynomial, y prime by this polynomial, and y double prime by this. Okay, to find the values of A, B, for C, D, and E. Let's do it. What we get? We get y double prime is 2c. This is 2c. We replace this by 2c. And y prime is 2cx plus d. Then plus. So here we have minus 2. Minus 2. Y is what? Y is this polynomial. Cx squared plus dx plus e equals to what? Equals to the right hand side. 2x squared minus 4x. We now try to rearrange the left hand side in terms of degrees of x. We're going to write down all x squared together, all x together, and all constants together. So here we have minus 2. Here we first multiply this negative 2 into the brackets. What we get? We get 2c plus 2cx plus d plus, sorry, minus 2cx squared minus 2dx minus 2e. It equals to 2x squared minus 4x. Now, استاتشيا كنجا يهاتي شي ماكل واي في ماند ازاين كامل ببي كيسه كهمان شكل راس بولينوميال دين چند داتا شام هم نقشكه او داتا شاب او واي بي ولا اي بم لي داني مو نقشك زاديم شي كم لا شكل راس ابي يكسان بي وايا دين شي كاين ببي 20 اكس كان همو اكس 20 دو كان بيكو همو اكس كان بيكو كونستانت كان شبيكو. Okay, let's see. How many terms do we have with x squared? We have only one term, which is minus 2c x squared. And this is x squared. How many x terms do we have? We have minus 2dx and 2cx. That means plus 2cx minus 2d. Let's take x as the common. 2c minus 2d x. Is it? And we have three constant terms, this, and that. We write down them all together. We don't need, because here we have not two. It's okay if even if we don't take it. We have 2c plus d minus 2e. It equals to what? Equals to 2x squared, no, minus 4x plus 0. Here we have two polynomials. In the left, we have a polynomial of degree 2, and in the right, we have a polynomial of degree 2. We say all the coefficients must be equal. Let me write down here. If we have, let's say, ax squared plus bx plus c equals to bx squared plus ex plus f. In this case, we say a equals to d. Is it? They must be equal. B must equal to E. C must equal to F. And then we say these two polynomials are equal. And here we have given that the polynomials are equal. So the coefficients of x squared in both sides of the equality must equal. The coefficients of x must equal, and the constant terms must equal also. Here, the coefficients of x squared here is minus 2x. So what's the coefficient of x squared on the right-hand side? It's 2. We equal the coefficients of x squared from both sides to 2. ليه ايش بها بشني راس ده بشوي بلا لا دواتك شو كناتو عن بشني تشوف وراس تاوري بس شوف ليه ام ديت يعني كيشان يا بها بشوي اسايا باشا ليه تشيك what we do we equal the coefficient of x squared in the left hand side to the coefficient of x squared in the right hand side. That means minus 2c equals 2. And then coefficient of x here is 2c minus 2d. It equals to what? In the right hand side, the coefficient of x is minus 4. Then the constant term to constant term. We have 2c plus d minus 2e equals 0. We have these three equations. From these three equations, we should find the values of c, d, and e. From the first equation, we can find the value of c. Directly, you can find it, okay? We say, from here, c equals to what? Equals to negative 1. And then we put it here. We get 2 times minus 1. Is it? We replace c by its value. Minus 2d equals minus 4. So what's the value of d? Here we get minus 4, minus 2, minus 2, minus 2d equals minus 4. So here d equals to what? Yes, that's 1. D is 1. It's positive 1. D equals 1. This is the value of d. And then we put values of c and d to the third equation to get the value of d. C is negative 1. So 2 times negative 1 plus 1 minus 2e equals 0. Here we get e equals minus 1.5. Is it? So what's yp? We just return these values to yp, and that's all. Look, yp here, we said that's it. We just replace values of c, d, and e here, and that will be yp. We say yp equals cx squared plus dx plus e. That's cx squared, as you see that's here. We just replace x, c, d, and e by their values here. Cx squared, which is minus x squared, plus dx, which is x, plus e, which is minus half. This is yp. And you also found yh. It's minus. Plus minus is minus. Okay? And you found yh also. It is a e to the power minus 2x. Let me check. Yeah. A e to the power minus 2x plus b e to the power x. The sum of these two is the general solution. So we see y equals yh plus yp, and equals a e to the power minus 2x plus b e to the power x minus x squared plus x minus a half. This is the solution. This is the solution of the differential equation. It's the sum of homogeneous solution and particular solution. And here we must test YP and YH if there is any similarity or not. There is no similarity here. That's why I didn't talk about that. Okay, here YP is a polynomial. As you see, YP is a polynomial and YH is an exponential function. So there is no similarity between them. That's why I didn't talk about that here. There is no similarity. Okay. If there is similarity between them, here YP becomes x to the power r, and then cx squared plus dx plus e. اگر هاتوا لك شو هبوا للنيوان YP كدائما ناو لقل YH كدوزيو معناته او كاتب بيويست شيبكين اما بقورين بيك اگر هشتا لك شو هبوا اي كين بدو برا اگر لك شو نبو صفر هاد ناينس ينتو هو كاركي اويا عندي فاي مان دازك يسا اشتكي واعمل باشا ايش ما دازك ك لا معقوله بون اريد دو يكسانه بس اشتي ما دازك لبد اويا okay we get some impossibilities and here let's solve it completely here. Yes, I'm gonna clean this, okay, because it's solved here all. This is YP, this is YP, this is YP prime, and this Y double P prime, YP double prime, and this is the solution. Okay, I'm gonna clean this one. It's not be like this. So now, it's too early. Okay, let me talk about another example, then we'll take a break. Okay. Okay, let's take a break. It's better. Let's take a break for 10 minutes. After 10 minutes, I will start, even if no one students return. Okay, take a break. We now have another example. We have given this second order differential equation. It says d squared of y by dx squared plus 2 dy by dx plus say equals x. Equals x. It says by using a method of undetermined coefficients, solve this differential equation. So in undetermined coefficients, what we do, we are going to find homogeneous solution and particular solution, and then we add the solutions, and it will be the solution or the general solution for the differential equation. For this differential equation, let's first find the homogeneous solution. Always you should find the homogeneous solution first. Okay, to find, sorry, yes, YH means homogeneous solution, YP particular solution. Yes. To find YH, what we do? We say we are going to take the homogeneous part of the equation. How? In the right hand side you have x, so you put 0 to the right hand side. Okay, and you say y double prime. I'm just going to write down in this form. Okay, y instead of d squared of y by dx squared. Y double prime means d squared of y by dx squared plus 2y prime equals 0. So what's the characteristic equation? I say the characteristic equation is, the characteristic equation is m squared plus 2m equals 0. Now let's solve the characteristic equation. We say m squared plus 2m equals 0. We take m as the common. So what's left? M plus 2 equals 0. Here we have m squared plus 2m equals 0. If we first factorize it, and we are going to find the values of m1 and m2. Here, what's m1? M1 is 0, and M2 is -2. So what's the solution? Here you have two different values for it. M1 is 0 and M2 is -2. That means they are real and different. So the general form of the homogeneous solution is okay. It's okay. Here you have a polynomial of degree 2. If we have x squared minus 2x, let's say plus 2x equals 0, what's the solution of this polynomial? Yeah, we take x as the common, and what's left? X plus 2 equals 0. Here we say either this is 0 or this one. From this one, we get x is 0. And from this one, we get x is -2. That means here we have these two solutions. Even this one is a polynomial of degree 2. It's the same. We just find the values of m. So now we say the values of m are different. Since they are different and real, so the homogeneous solution equals e to the power m1x. What's m1? 0. Plus b e to the power m2x, which is -2 x, and yh equals a plus b e to the power -2x. Okay, this is the homogeneous solution. And to find the particular solution, what we do? We look at the right-hand side of the given equation. In the right-hand side, what we have? We have a polynomial of degree 1. We have a polynomial of degree 1. That means yp should be cx plus d. Is it? We must have the general form of polynomial degree 1, which is cx plus d. We say yp equals, we say for r to be 0, here we say the general form of yp for polynomial, yp equals x to the power r, x to the power r, ax plus, sorry, cx plus d, cx plus d. If r to be 0, we always start from 0. F to 0, and if there is no similar terms between yp and yh, we say that's okay. We follow the steps. If we always find the homogeneous solution. Look, we found it. We always find the homogeneous solution. Okay. Then, when we let the particular solution for r to be 0, if r to be 0, we have to know this theorem. That's it. You say yp equals cx plus d. Do we have a similar term between these two? Yes. We have a constant in each, a and d. Those two terms are constants. They are similar. So we cannot take this one. What we do, we are going to give 1 to r. If r to be 1. So if r to be 1, what we say? Yp equals x times cx plus d. Now we multiply this into the brackets. We get cx squared plus dx. أقول لك شو هبو؟ أنا x بتواني يقول لك. استبزام لك شو هيا؟ نية. أقول هبوايا. أقول x تجام ولا قست. رقم كلمة دو. باشا عملي r سنة. رقم يكا. For r to be 1. This is the general form. Let's return to the general form here. This one is the general form. We say yp equals x to the power r times the polynomial of degree n. Okay. We start from 0 for R. If there is similar terms, we are gonna give 1, then 2, then 3, and so on. Okay. And here we have this. Here you have no similar terms with YH. No similar terms. There is no similar terms. Here you have a constant, but here you have dx. They are not similar. And here you have cx squared. We have no x squared terms here. That's why there is no similar terms here. So we choose this one. We choose this for yp. That means yp is cx squared plus dx. And then what we do, we are going to find here yp equals cx squared plus dx. How many derivatives do you have in the equation? We have this square root of y by dx squared means second derivative and also first derivative. So you must find them both for yp. We say yp prime. Yes, of course. Yp prime equals 2cx plus d. And then yp double prime equals 2c. Is it? Now we return them to the given differential equation. The differential equation is y double prime plus 2y prime equals x. This is the given differential equation. Put in this. This is the given differential equation. As you see here, we have given y double prime plus 2y prime equals x. Now we replace y double prime by 2c. So you get 2c plus 2 times y prime. Y prime is 2c plus d. If you multiply this by 2, we get 4cx plus 2d equals to what? In the right hand side, you have x. Now we equal x term to x term, constant term to constant term. But in the right hand side, we have no constant term. That means it's 0. If there is no any term, means that's 0. That's the coefficient is 0 there. Here we say 4c equals the coefficient of x. The coefficient of x in the left hand side equals to the coefficient of x in the right hand side. In the left hand side, you have 4c. So from this 4c equals 1 and c equals 1/4. And also we have 2c plus 2d equals 0. Because these are constant terms. We have no x in these terms. That means from both sides must be equal. We say 2c plus 2d equals 0. If c to be 1/4, this 1/4, we found this one. We found this. So if you replace c by 1/4, what we get? We are going to replace this here. We get 1/2 plus 2d equals 0. And from this, d is minus 1/4. This minus 1/4. This is d. So you found c and d. Let's write down the particle solution. We are going to return the values of c and d to yp. To here. We get yp equals c x squared. What's c? C is 1/4 plus d x. D is minus 1/4. This is yp. And we found yh also. The sum of these two solutions is the general solution. Look, the process is that we first find yh, then we choose yp, the suitable yp. It depends on r to be 0, 1, 2, and so on. And then we are going to find yp After finding yp, we say y equals yh plus yp. YH is a plus b e to the power x minus 2x, sorry, plus the particular solution. In the particular solution, we should find the values of constants. How? By taking the derivatives and then substituting them into the differential equation, comparing both sides and the coefficients of both sides for x squared and x and so on must be equal. Then we get the values of constants. After finding the values of constants, we return them to the chosen particular solution. Here we get 1/4 x squared minus 1/4 x. This is the solution. A plus b e to the power minus 2x plus 1/4 x squared minus 1/4 x. This is the solution for the differential equation. Okay. We'll take some more examples in the other cases, and it will be much easier. And if the right-hand side is an exponential function, in these cases, we say the right-hand side is not 0. And the right-hand side, it could be polynomial, it could be exponential function, it could be sine or cosine, and also it could be the sum of these cases. Here, we say if the right-hand side is an exponential function, if the c e to the power mx, we say yp equals x to the power r d e to the power mx. Look, here we also have x to the power r. We choose r 0 first. If there is similarity between yp and the homogeneous solution, we change it to 1. If there is still similarity, we change it to 2, and so on.
Is there any way to remind me whether the value we put in the R because the different?
No, we must first find yh. I know.
To preserve the time in the answer.
Look, here we say we choose R 0 first. After finding YH and then choosing YP, then we know that what's the value of R. We don't know before. There is no any rule from looking at the example to know that that's R is 0, 1, or 2, or any other number.
But sorry, it gives you like 3 options.
Yeah.
So won't be like wiser just for saving the time to try, for example, number 1.
Okay. You mean I choose 1 here?
Instead of 0, 1.
Okay. Look, if for 0 are different, you must use 0. You must start from 0. You don't have to start from 1. Okay?
Or any other number.
سك أقرب للصفر جواز بون نبي بليك باشا أقل للصفر ليك شو هبو إنجا عليه وأقل ليك جواز بون إنجا عليه هو شوية. بالي يان صفر أنا كان دو لو أنا بس لو أنا ببوين نبي كبوين نبي جاي
بس لا ساسوني
سلسيش للساسوني. اوكي كي ازاني تشي بو بيت وايج دوزينو homogeneous solution كاتي كواي بي هلب جيري مزاين ليك شو هي يعني اقل ليك شو هو انجاي. Okay, here we have an example. It says y double prime plus y prime minus 2y equals 5a to the power 3x. As you see in the right hand side, we have no polynomial. We have an exponential function. And we said for exponential functions, we choose x to the power r, d, e to the power mx. D is a constant. You can say c, a, or any other number, any other constant. We say first we should find the homogeneous solution. This is the characteristic equation. First, we should write down the homogeneous form homogeneous part. We say y double prime plus y prime minus 2y equals 0. It equals 0. Here the characteristic equation is m squared minus m plus m minus 2 equals 0. Here m1 equals 2, so negative 2, and m2 is 1. These are the values of it. Solving that, we solved this before. That's why I'm not gonna solve step by step. Here YH, which is the homogeneous solution. As you see, here we have two different values for M. If they are equal, we have a case. If they are different, we have a case. If they are complex, we have another case. We have these three cases for finding the homogeneous solution. We say the homogeneous solution is a e to the power m1x, which is minus 2x, plus b e to the power m2x, which is x. This is the homogeneous solution. And now we choose the particle solution. Since the right hand side is an exponential function, so the particle solution must be in this form. We say yp must be in the form of x to the power r. This is c e to the power mx. What's m here? M is 3. We choose the same. Okay? We choose the same. M is 3. But c is a constant. Then we choose r to be 0 first. Then r to be 1 and so on. If there is similarity. If there is no similarity, we just choose r to be 0. Here, for r to be 0, we say yp, if r to be 0 here, x to the power r is 1. It means x to the power 0. So we get 1 here. We get 1. That means we get c e to the power 3x. C e to the power 3x. Is there similar terms between these two? For the exponentials, we must have the same exponent in both. Then we say that they are similar. If this is 2, so if this is x. In this case, we have similarity because b e to the power x and c e to the power x, both exponents of e are the same in homogeneous solution and the particle solution. But here we have 3x. Here we have 3x. Do we have e to the power 3x in the homogeneous solution? We have no e to the power 3x in the homogeneous solution. Here we have no e to the power 3x. That means there is no similar terms. So it's no. There is no similar terms. That means this is the particle solution that we choose. We don't need to try r to be 1. Because even if r to be 0, there is no similarity. Now, what we do? We are going to find yp. We are going to find yp. We say yp equals c e to the power 3x. Here we should find the value of this constant. Here we have c only. We should find the value of c. We say y prime of p equals 3c e to the power 3x. Y double prime of p equals 9c e to the power 3x. Look, in the equation we have only up to second derivative. We have derivatives up to 2, up to order 2, I mean. We are going to replace y double prime by yp double prime, y prime by yp prime, y here by yp, and we have the right hand side also. We say y double prime plus y prime minus 2y equals e5 e to the power 3x. Diğer arkadaşlar berdemi amina amiye her şeye göre şaşaman niye cüynayne yani neyse بس يك خوي نسيم لجي أو بينج شيء داني كونستان ليه شيء من داناوا سي من داناوا باشا بلام توانه كه همان توان بهمان توان داني له. Now we replace y double prime by 9c e to the power 3x. 9c e to the power 3x plus y prime is 3c e to the power 3x minus 2 times y. So that's yp. Minus 2 times c e to the power 3x minus 2c e to the power 3x. It equals what? 5 e to the power 3x. Now we can find the value of c. In the left-hand side, all terms include e to the power 3x. So you can just add their coefficients. Okay? We say 9c plus 3c is 12c. Minus 2c, sorry. Minus 2c is 10c, is it? 10c e to the power 3x equals 5 e to the power 3x. These two e to the power 3x can be cancelled out by dividing both sides by e to the power 3x. So it's left. We get 10c equals 5. So how about c is 1.5. This is the value of c. That means yp equals 1/2 e to the power 3x. This is yp. And we found yh also. That's it. The sum of these two is the general solution. We say y of x is yh plus yp. This is yh and this is yp. As you see, this is yp and yh is a plus b, a e to the power minus 2x plus b e to the power x. The same as we found. That's the general solution and that's the final answer. We have another case, I'm sorry, it's the same case, sorry. Still we have a in the right hand side in this example. To solve this, what we do, we should first find yh, I mean homogeneous solution, and then particular solution. We choose a suitable particular solution for the equation. Let's first find the homogeneous solution. We say the characteristic, first write down the homogeneous part of the equation. We get y double prime plus 2y prime equals 0. And here, the characteristic equation is, you should write down the characteristic equation. Is m squared plus 2m equals 0. And from this, we can say m1 equals 0 and m2 equals -2. Is it? We take m as the common, either m is 0 or m plus 2 is 0. From m plus 2 to be 0, we get m is -2. Here we have these two different values for m. 0 and -2. That means the homogeneous solution is a e to the power 0x, which is 1. This is 1. We get only 1. Plus b e to the power minus 2x. This is the homogeneous solution. Now, we choose the suitable particular solution. Since the right-hand side is an exponential function, so the particular solution must be in this form: x to the power r, let's say c e to the power mx. What's m? M is the coefficient of x, which is in the exponent in the right-hand side of the equation. It's this one. This is m. This is m. M is -2. Okay. Now we say yp equals, for r to be 0, what we get? This term is 1. X to the power r. X to the power 0 is 1. So we get yp is c e to the power minus 2x. Do we have similarity between this and the homogeneous solution? Yes, we have e to the same exponents. There e between ناقص 2 man the homogeneous solution كهي. Look, in the previous example, we say e between cx man here, Niemann. But here we have the same exponent for y, for e. As you see, it's minus 2x, and here you have x e to the minus 2x also. That means there is similarity. Yes. Okay. Even for the polynomials, we just looked at the degree of the terms. لا polynomial كانشا amount x دوجا كونستان بتنيا هبي هاشتك ونيا ليكشو. Okay, for this one, yes, we say there is similar terms, so we choose r to be 1. For first, when r to be 0, we got similar terms, and now we choose r to be 1. What we get? We say it is yp equals x to the power 1 c e to the power minus 2x. Now we have x which is multiplied by an exponential function. Do we have any similar term to that one? No, because in above we have no x which is multiplied by any of the exponential functions. That means this is different. So it's, there is no similarity. There is no similar terms between this yp when r to be 1. Look this, if r to be 1 here, what we get? We get x times e to the power m c e to the power mx. This is yp. So for this yp, we have no similar terms with the homogeneous solution. Now what we do, we are going to find the derivatives of this yp, then turning into the differential equation to find the value of c. Here we do this for only finding the value of c. We say yp equals c x e to the power minus 2x. What's y prime of p? Here we have multiplication of two functions. Let's say this is a function and that's a function. We have x multiplied by e to the power minus 2x. Let's say this is f, this is g. Derivative of f times g is f times g prime plus g times f prime. Is it? That's the rule. Here we have x times e. Okay. We say yp equals cx times derivative of e to the power minus 2x is minus 2 e to the power minus 2x. ليه؟ لأن هي كم ضربة تساوي دون زائد دون كردة تساوي. Then plus c e to the power minus 2x. Derivative of the first one, derivative of x is 1 times 1. This is the derivative. Now let's simplify it. We get equals minus 2c x e to the power minus 2x plus c e to the power minus 2x. This is y prime. And for y double prime, we are going to find a derivative for this function. We say y double prime of p equals. For the first term, I mean for minus 2cx e to the power minus 2x, here we have multiplication of two functions, which are x and e to the power minus 2x. First times derivative of the second plus second times derivative of the first. We apply that rule. Here we get minus 2c x times minus 2 e to the power minus 2x. It's first times derivative of the second. Then plus second times derivative of the first. Minus 2c e to the power minus 2x times derivative of x is 1. Then plus derivative of the second term is minus 2 c e to the power minus 2x. Is it? Because derivative of the exponential function is the exponential times derivative of the exponent. If you have e to the power u, its derivative is u prime times e to the power u. This is the rule for finding derivative of exponential function. Now, let's simplify this. We say y double prime of p equals minus 2 times minus 2 is 4 cx e to the power minus 2x plus. Here we have minus 2 times 1 is still minus 2. Minus 2 c e to the power minus 2x. Then here we have minus 2 c e to the power minus 2x equals to what? Sorry. This equals, these two are the same. We just add them. We get minus 4. We get 4 cx e to the power minus 2x minus 4 c e to the power minus 2x. Now we replace y prime and y double prime by their values. Here we found y prime and y double prime. The equation is y double prime plus, is plus or minus, plus 2y prime. Y double prime plus 2y prime equals 3 e to the power minus 2x. This is the given differential equation. Here, we say, first let's write down something here. We say substitute y prime and y double prime into the given differential equation. So the differential equation is y double prime plus 2y prime equals 3 e to the power minus 2x. Let's replace y double prime. Y double prime is this function. We say it's 4 cx e to the power minus 2x minus 4 c e to the power minus 2x. Then plus 2 times y prime. This is y prime. This is y prime. Okay? We're going to multiply it by 2. And we get minus 4 cx e to the power minus 2x plus 2c e to the power minus 2x equals to what? 3 e to the power minus 2x. We just replace y and y double prime by the values here. But in the equation, we have 2 times y prime. That means we are going to multiply all terms into y prime by 2. These two are going to be cancelled out. What's left? We get minus 2 c e to the power minus 2x. These two are similar. Here we have minus 4 and 2. So you get minus 2 equals 3 e to the power minus 2x. Now from this, these two are cancelled out because they are the same. By dividing both sides by e to the power minus 2x, we get minus 2c equals 3. So c is minus 3 over 2. This is 3. This is c. So how about yp? Yp equals to what? We said yp is cx e to the power minus 2x. We just replace c by its value. It's minus 3 over 2 x e to the power minus 2x. This is yp. How about the final answer? So for the final answer, if it's not written there, I'm going to write down it. We say y equals yp plus yh. Let me write down this first. Plus yp. So what's yh? Yh is a plus b e to the power minus 2x. This is yh. A plus b e to the power minus 2x. So how about yp? Yp is minus 3 over 2. So this becomes negative. X e to the power minus 2x. These are homogeneous. And this one is particular solution. That's the solution for that example. Look, may takes time, but it's so easy. Okay, just don't be confused in solving the equation. First, find YH, I mean the homogeneous solution. After find the homogeneous solution, choose the suitable YP. After choosing YP, we are gonna find first and second derivative of YP, then return it to the differential equation. When we return to the differential equation, we can get the value of constants in the particular solution. After finding the constants, we replace them in YP. Then we just add YH and YP to get the general solution. We say the general solution is the homogeneous solution plus particular solution. That's all steps that I did here. So it's enough for today. For next